Hello, my name is Amir from ProBasic. In this video I'm going to teach you how to write binary files and read binary files in C#. This video is a follow-on from my last video, which basically discussed how to read binary files in C++. So I'm going to pick up from where I left off, and I'm going to pretty much start just to give you an idea what binary files are. Binary files are basically, as the name suggests, a sequence of zeros and ones. As a matter of fact, all files which exist on a computer system are binary files, even text files. From a programmer's point of view, there is virtually no difference between a binary file which cannot be opened in a notepad and a text file which can be opened up in a notepad, because essentially they are still made up of sequences of zeros and ones. These sequences of zeros and ones are grouped together in an 8-bit sequence to form 1 byte. So you can say basically that a binary file is a collection of bytes, of course written in a specific manner. So we're going to just start off, and what we're going to do is we're going to still use that AVI file to read the header information of an AVI file. I've done it in C++, and I'm going to show you how to do it in C#. It's a bit tricky because these languages like C# and Java are not really designed with the flexibility, I would say, for the lack of a better word, or the simplicity of C++. But anyway, that's my personal opinion. Let's just start now. So this structure here, which says AVI header, describes what the header of a binary file looks like. And for people who do not know, the header of an AVI file is 88 bytes long. And how do I know it? Well, the thing is, if you add up how many bytes each element of this structure occupies, you will get to the magic number of 88. So let's start by discussing the first element. I'm just going to uncomment it. The first 32 bytes, which basically is an array of unsigned integer. The reason I'm using unsigned integer here, because when you are reading values from a binary files, those values have certain meanings, and in this case the meaning is the value you're going to get is a positive value, which basically means is that you would not get any negative values. For example, if I were to say how many frames make up this AVI file, it can never be a negative number, because you cannot have less than at least 1 frame in an AVI file. So that's why unsigned integer is being used. Unsigned essentially means positive integer. So we basically go through these attributes, and I'm not going to discuss all of them, but just to let you know, it's a very simplistic file structure, because AVI itself is a very old file structure. If you were to go and start parsing files like MP3 or MP4s, you would find that the data structures which make up these files are fairly complex. One of the reasons I chose AVI is because its header is very easy to parse, very easy for newbies or people beginning in the industry of programming to understand. So I'm just gonna talk you through all the elements just very quickly. The second element, the first element essentially is an array of unsigned integers of 8 integers totaling 32 bytes in size. Now, from an information point of view, it is there, it has a meaning. However, for what I'm trying to illustrate, there is not much there. There's not much information in there to display or to see any meaningful information. I'm going to uncomment it, and once I move down the file, I'll tell you why I've uncommented it. This basically tells you what is the time lag between one frame and the other frame. So for example, if there are 25 frames played per second, then the time lag between one frame and the second frame is about 40 microseconds, something like that. Now, why is it important? Well, you see, all video players use a thing called precision timers to draw images on the screen, and they need to know how far behind each frame is from one another so they can play their movie correctly. Also, the thing is, the second basically tells is that this AVI, you would have to read so many bytes per second from this file. Again, comes down to precision timing, which is another discussion for another video. What precision timing is. Precision timing, just to let you know, just to give you a very brief introduction, is to run a loop, but to do it in such a way that it would only run X times per second. Not 100, not 20. Let's say, for example, I want the loop to run 20 frames or 20 times per second. So past base is 25 times per second. That's what basically a precision loop really is. So this structure essentially, just very quickly, show you the padding, show you the flag, show you the total frames, so the initial frames, stream size, basically tells you how many streams are there inside that file. Just to let you know, guys, AVI can have multiple streams. Well, traditionally AVI file would have at least 2 streams, 1 video stream, 1 audio stream, but it can have multiple audio and multiple video streams. However, there are not many players in the market who support this. What is the width and the height of the frame? And the last are reserved again for the purpose of this demonstration. These are not really all that important. They are important to the people who wrote the AVI file, but not to this presentation. We're going to leave this. I'm not going to go into detail how to read this file in C++ because I've already shown it in another video. I'm going to quickly switch over to C#, and we'll try to represent the same AVI header inside the C# file. Okay, we're going to stop. C# has the same concept of structures as C or C++ do, but there is a difference. When you define a structure in C#, the way it looks on the file and the way it looks in the memory are two different things. Now in C++, it's not it. The header looks exactly like the way it is written on the file. It looks exactly like the way it looks in the memory. But in C# would try to optimize this header, compress it, compact it, move fields around. We don't want this. We basically want this structure to look in the memory when it's loaded into the computer memory to look exactly the way it is written. So we're going to start this directive structure layout kind of sequential. Essentially means is that do not optimize this structure, leave it the way it is. Next, basically saying the character set we're going to read is 1 byte. Essentially, we are not reading Unicode. We are basically reading 1 byte. We're not reading 16 bits or 2 bytes. We're reading 1 byte. So we're basically saying the character set is 8 bits or 1 byte. This is not so relevant now, but I'll tell you what exactly it means. In certain structures you would find, not an AVI per se, but in certain structures you would find that the boundaries between various elements which make up the structures are not even. For example, you could have an array of 5 bytes followed by unsigned short, which is 2 bytes, followed by array of 7 bytes. So what will happen is, you see, all 32-bit systems like to read informations in the multiple of 4 bytes, 32 bits basically. And what will happen is that when you write this structure in C++ or write this structure in C# and try to load it up, you would find that extra padding is applied within this structure, even when you assign to the compiler layout is sequential, to optimize that structure for reading in the multiples of 4 bytes each. So we don't want it to happen. But here it's redundant in a way that AVI structure always reads in the multiples of 4 bytes. So if I remove that, it's not going to make any difference. But I'll tell you what, if you are dealing with structures which have boundaries which are in odd numbers, for example, just I showed you 5 byte characters followed by 2 bytes followed by 3 bytes followed by 8 bytes, so you'd find the whole thing is a bit uneven, so you probably want to drop it off, just sort of tracking 1 byte. Essentially that's what it means, to make sure that the structure perfectly aligns itself with the file you're trying to read. So moving on, we're saying is that if you remember the first element of that was 32-byte array. Although it does not contain any meaningful information, for the purposes of reading the file, it has to be included in the ABI structure. So basically saying is that the next line, this line, public unsigned 32, you're going to marshal it as an unmanaged type. Unmanaged type essentially means is map it to a C or C++ type array, and it's the size of 8 bytes. Sorry, with the size of 8, not 8 bytes, 32. So basically we're saying is that we are creating an array of unsigned 32-bit integers, and we're going to have 8 of them in this array. Basically, again, this is very simple. Essentially saying marshal as, again, marshal means represent this as unmanaged type, unsigned 4-byte integer, and next is public unsigned integer, and this basically goes on and on. I'm essentially repeating myself here, that basically all it's doing is that the C# data types have to be presented, marshaled in such a way that they map perfectly with the unmanaged type. And I'll tell you the reason why. You would find that despite of the languages like C# and Java or any other high-level languages, most files today are written either C++ or C. Reason? Speed. One thing. And also most of the people who create these file structures, because let me tell you right now, it's not very easy job to create file structures. You need to be a very experienced programmer to be able to do complex file structures, and these people are masters in their field. And you would find as your programming skills grow, as you become a more proficient programmer, you would start moving back. If you're not already doing C++, you would find yourself leaning that way, because you'd find that these languages are far more flexible, efficient than anything C# or Java would ever be, because languages like C# and Java are also written in C++. Basically, they provide extra bit of shielding, extra bit of comfort zone for people new to programming. But that's where I'm coming from, essentially, that this is the reason that why C# data types have to be marshaled as basic type databases, for the lack of a better word, because most files you'd find are written usually in C or C++. So moving on. So basically we keep repeating ourselves, keep doing the same thing again, marshal as unsigned type. Just let you know that if I were to just click here and go, you see there are a whole lot of options there. So the thing is that you are not restricted to just marshalling them as an integer. You basically you can marshal them anytime you like. You just have to look at the file structure of your file. In my case, it kind of makes sense to marshal it as a 4-byte unsigned integer. But in your case, if you're marshalling any other file, you basically have to look, study the structure of those files. Now, not many files in the market have their internal structures or the way they were written exposed to programmers. But if you head over to open source projects, for example, MKB files, for example, you would find that what structures, what things go and make up MKB file are fairly well documented. If you were to go to LAME, L-A-M-E, which is a parser for MP3 files, you'd find within the C headers of that file, that program or that library, you'd find that MP3 files are fairly well documented. But anyway, moving on. We basically have created a structure where bytes are perfectly aligned, and we come down to this function here. What it does is it takes in an array of bytes and maps them to a ABI header. Basically, that's how files are read in C#. So I'm going to start from the very beginning. In my main program, I basically go and open up a file, same file which I opened in C++. please see my other video on how to read binary files in C++. So we basically open the file and we get a file stream called reader from it. Now we create an array of 88 bytes. Now how do I know it's 88 bytes? Because I studied the file structure of a AVI header, I know what it is. In your case, you have to, if you're trying to read some other header, you have to find out what is the length, and if it's an open source project, or if there is publicly available data structures which define it, you'll be able to get that information fairly easily. So what we do is we've created an array of 88 bytes. And we basically open up the read statement. We're basically saying that fill this byte array of 88 bytes with the first 88 bytes you read from this file. We start at position 0 and go to position 88. And once we have done it, we close it. Just to let you know, guys, that in C#, anything which is created with a new keyword is always passed to a function by reference. Basically what you're doing is you're doing this is the C++ equivalent of byte G. This is the C++ equivalent, is equal to new byte so that's what it is. Essentially you're creating a pointer to an array created by the new keywords and allocate 88 bytes, and that pointer is passing to it. That's the C++ equivalent basically there. And to tell you the truth, this is exactly what it happens in C#, except two things. First, all byte arrays, when they're created, you can basically get the length in C++. You can't just get the length by looking at the pointer. And second of all is every object or every other array created in C# does not have to be deleted manually. Like for example, if I were to create this structure in C++, I have to follow it up with this. Essentially, sorry, D-E-L-E-T-E. Sorry, my spellings are horrible, man. D-E-L-E-J. So I have to follow it up with a D keyword. In C#, I don't have to, because C# has a automatic garbage collection. So once I allocate an object, either the program goes out of scope, it exits, then the memory would be freed, or when the garbage collection runs and finds that there are no more reference to that variable, then it'll free up the memory. But anyway, moving on, let's not get sidetracked here, I guess. Okay, so here we create an instance of AVI header, the same structure. In C#, all structures can be created by basically just creating an instance of it, an AVI header. And then we come down to this byte mapper, and I'll tell you, this is where the magic sort of begins. So as soon as byte mapper, the program control goes into this function, and we push in the array which will hold, which basically have got the bytes which you've just read the bytes using the read method into this read bytes array. And out essentially means is that generally you'd find, in programs you would pass arguments into the function. Out keywords are used in languages like C# to telling you that it's gone, and some information would be actually pushed out of the system. So moving on, what will happen is that this method gcalloc essentially means is create a region of memory with read bytes as one of the arguments and pin that memory down, which basically means is that do not allow the garbage collector to move that memory out from the program's active memory. Essentially, they're basically saying that I'm going to read these bytes and I want them to be pinned into the memory. Next essentially is the Marshall pointer to structure method of the class Marshall. Basically what it does is that it basically what it does, sorry about that, is that I'm just trying to think of lack of a better word here. It basically takes that array of the bytes which you have read and maps them to the AVI header structure. Now I keep going to the factors, and what it does, it returns the AVI. It returns the AVI structure, where you have to cast it to a AVI structure and put it to this variable which is already pointing to the AVI header. And once you've done, basically you free the packet. And since you're using out, which basically means that the AVI header would now be basically available with all the information needed. And I'm just going to prove that this thing works to you, because I've read the structure and I've read these information. I've read the width and height of the frame, and I've also read the total number of frames, and I'm going to run this program for you right now. And there it is. The width is 720 pixels, the height is 540, and the total number of frames is 22,318. I'm sure it's gone. I'll run it for you again. Okay, there you go. So the height is 540 pixels, and the total number of frames in this is 22,318. And surprise, surprise, when we run the same program using the same file in C++, we get the same results. Basically, you can look. This was C#. This is C++. Width 540, 22,318 frames. So we know that we have run the same program in C++. We have run the same program in C#. We know our method works. But just to let you know, guys, reading AVI files in C# is a bit tricky, and a lot of practice is required. And besides a lot of practice, what is further required is a very deep understanding of how the file is actually laid out, because this is one thing in life. If you are in and out by even a single byte, your whole parsing would not make any sense at all. So kind of keep that in mind. If you have any comments, any questions, post them on this video page, and I'll be happy to answer them for you. All the best. Good luck. Bye.